Hey guys, today I will be working on AP Calculus AP final exam walkthrough. You can also use this video to prepare your upcoming AP Calculus AP exams. So let's just get started. All right, so the first question is taking the integral of 5e to the 2x plus 1 over x dx. So basically, in order to start the question, you have to know how to take the integral of e to the x. So if you take the integral of e to the x, you would get e to the x plus c. However, in our case, we have e to the 2x, which changes everything. So if we have e to the 2x, I'm going to have e to the 2x as well. But the only difference will be I'm going to have a 2 in the denominator. Remember, guys, if you have an exponent in e and you're taking the integral, you can just think about it as bringing that to the denominator in order to achieve your integral. If you're not sure of this, you can basically simply just take the derivative of this, and you would have to get e to the 2x. So taking the integral of e to the 2x over 2, you would get 2 times e to the 2x divided by 2, which will satisfy e to the 2x, which is the thing we started with. All right, so let's just get started. So taking the integral 5 e to the 2x divided by 2, because we have 2 on the exponent, plus, and I got 1 over x. So what is 1 over x, guys? 1 over x is x to the negative first power. But I can't take the integral, because if I just add 1, I get x to the 0, and I can't divide with 0. So therefore, there is a rule. Basically, you're just taking ln of absolute value of x when you're integrating 1 over x. Also, the same thing applies for the derivative. If you're taking the derivative of ln of x, you're getting the 1 over x as your answer. Also, don't you forget your plus c, and the answer choice should be where? Answer choice B. Question number 2. If f of x equals to radical x plus 3 over radical x, then f derivative, or f prime, 4. So firstly, you have to take the derivative, obviously. So just take it. Just take it, man. This is x to the 1/2 power because it's a radical, plus 3 times x to the negative 1/2 power because it's on the denominator and it's a radical. So you just basically should know that from maybe algebra 2. And this should be actually, this is the form. I just wrote it in a different way to simplify taking the derivative process. So now let's just take the derivative of this thing. It will be 1/2 x, subtract 1 from the exponent, which you would get negative 1 over x, plus 3 times negative 1/2 x to the negative 3/2. Now, let's just rewrite everything so I can just plug the 4 in, because this is our actual derivative. But I want to make it looking prettier, so I can just plug my numbers in. So 1 over radical x plus negative 3 over 2. Let's actually make this a minus 2 halves minus 3 halves times x radical x. Yeah. Um, yeah, it looks like this is my derivative. And now just plugging 4, I should get 1 over 2 times radical 4 minus 3 over 2 times 4 times radical 4. And this will give me 2 times 2, 4. 2 times 4, 8. 8 times 2, 16. So 1 over 4 minus 3 over 16. Now, this will be giving me, if I just duplicate with 4, I would get 1 over 16 as my answer choice. Another question, question number 3. So basically what just pops into my eye is there's a U substitution. So how do I come to this conclusion? Basically, if you just simply see, we have two exponents, which is x squared and x to the 5th power, and we don't want to just multiply everything with x squared and firstly take the exponent, which is over 6, and then do all of that stuff. That's just impossible. Like, not impossible, but it would take your day. And just simply use your u substitution. So x cubed plus 5 equals to u. Take the derivative. Du dx is equal to 3x squared. Now, what is dx in terms of du over something? Du over 3x squared is equal to dx. How do I come to this conclusion? You just can't just write 1 and just cross multiply and then send this 3x squared to the bottom, and you end up with this. So I'm just going to use my u substitution in the integral. X squared times u times du over 3x squared. Now, we can just simplify this x squares, and I got a u times, actually, I was almost forgetting this, over power to the power of 6. So write this power 6 too, and du over 3. Now just take the integral like a simple variable, and you just end up with u to the 7th power divided by 7 times 1 over 3. And also don't forget your plus c. And what was x? We have to write x. So x cubed plus 5 to the power of 7 divided by 21 plus c. We should have that. We can just write this 1 over 21. So yeah, looks like answer choice C. All right, question number 4. The values of a continuous function f for selected values of x are given in the table above. What is the value of the left Riemann sum approximation to integral 0 to 50 f of x dx using the sum intervals of this? So if you want to find your left Riemann sum, just so you know, I want to just make a graph over here. Like, let's say I got a function like looks like this. So left Riemann sum is basically there are rectangles, all right, to fill out this area under the curve. And as you might notice, actually, I'm not a perfect drawer, but let me just try to make it prettier for you. So as you may notice, there are some spaces between these lines and the rectangles which I just draw. The reason being is we're using left-hand summation. So we're just going to multiply the left hand times our subinterval, which in the question we're just going to find. And this is going to give our rectangles area. So we're going to have an under approximation. Also, it depends on which case you're looking at. If you're looking on concave down or concave up, it could also differ, or even actually in a linear path, it can differ anyway. So just so you understand the point, you just use your left y value. This is your y value, guys. So you use your left y value and just multiply with your subintervals. So our left value will be 4 in this case, and our subinterval is 25 minus 0. So 25 minus 0 times 4. So for our first value, we got 100. Plus, let's jump into our second value. 25, 30, and 60. So our subinterval will be 30 minus 25 times 6, and this will give me 30. Okay. Did I do something wrong? 30 minus 25, 5 times 6, 30. Yeah, looks correct. And now, last but not least, I got what did I got? 50 and 30. So we're just gonna say plus 50 minus 30 times 8, and this would give me 160. Now, adding these values, I got 290 as my integral for left Riemann sum approximation. Now, let's jump into question number 5. Let f be the function defined above, where c is a constant. For what value of c, if any, is f continuous at x equals 2? So basically, guys, a function is something looks like this, right? This is actually more likely a continuous function. However, let's say for this point, I got my value down here. It looks like something like this. This is not a continuous function. So basically, in this question, we're trying to satisfy this requirement by making this two-way function, as you may, something look like something else. Like we have to set this values equal to each other. So we will make sure our function is not jumping to anywhere, if you may. So how can I do that? First of all, we're gonna plug 2 for our x values to get that point. So if I just plug 2 over here, I would get 4 times sine times 2 pi. All right, and set that equal to 4 plus 2c minus 18. So 4 sine of 2 pi is equal to 2c minus 14. And now over here, we can see that sine of 360 and 2 pi in degrees is 360 degrees is 0. So sine of 2 pi is 0. 4 times 0 is 0. So we have to get 0 for the right side as well, since they're equal. So c should be 7 in order to satisfy this equation, which will give me answer choice B. Which of the following is an antiderivative of 3 secant square x plus 2? Antiderivative is just a fancy way of saying integral. So just take the integral of 3 secant square x plus 2. So guys, secant square x is just the derivative of tangent of x. So if you take the derivative of tangent of x, you're going to get secant square of x. So basically, if you take the integral of 3 secant square of x, you're going to get tangent x. So for here, I'm going to get 3 tangent x. Also, I'm based on the question, this should be dx. So I would also get 2x. So I'm just multiplying with x plus my c. And that should be answer choice B. Guys, just don't make this mistake. Like if I'm just taking the integral of 3, for example, in dx, we're just multiplying that with the variable which you're working with. So in this case, dx, or you may x. If f of x equals to x squared minus 4 and g is a differentiable function of x, which is the necessary information to solve this question, what is the derivative of this? So basically use your chain rule, and chain rule just states if you want to take the derivative of this, you have to just do f prime of whatever is inside times g prime also times x prime. Like usually x is just 1, x prime is 1, but if there's anything else in this form, you have to like also take the derivative. If like for example it's 3x, you just multiply with 3. Anyway, now our function is this. So I'm just gonna plug g of x into this function because g of x is inside of f of x. So g square of x minus 4, and you want me to take the derivative of this. So g of x to the power of 2 minus 4. How can I take the derivative? So basically, a constant's derivative is 0, so you just don't think about this. And 2 times g of x um, times g to the g prime of x. Yeah, so it should be d. All right, so question number 8, we're basically asked to find the limits when x approaches infinity to g of x, and our slope field is dy dx y squared times 4 minus y squared, and y is g of x, and g negative 2 is negative 1. So basically, over here, we got when we just add up our slopes together, we got something which approaches to infinity, but not exactly. So if x approaches infinity, I mean, it approaches to 0 because it never touches the x-axis, or actually even like be able to cross the x-axis. So basically, I would say the solution to the limits x approaches infinity to g of x would be 0. Question number 9. If f double prime of x equals to this, then the graph of f is concave up for what? So basically, guys, for concavity, we use our second derivative and set that equal to 0. When x changes signs, and also when x is 0, at that point in the second derivative, that means that our x is changing concavity. So we're just going to do that and set this to equal to 0 to find our points of inflection, and our points of inflection would show us a guidance for when is the f is concave up and when is not. So also you can just use a graph and just graph any kind, like you can graph f or f prime or f double prime. There are many ways to find when it's concave up or not, but this is a mathematical way how to do it. So x times x plus 2 squared equals to 0. Now, how can I set this equal to 0? So either my x will be negative 2, which I will call x1, and the other option is x2 is going to be equal to 0. So if I set x equal to negative 2, this will be 0, and I will get 0. If I set 0, 0 times 2 square, which is 4, will also give me 0. So for which values is my graph concave up? So now we're just going to, I mean, I didn't mean to draw this. Instead, let's draw this. 0 and negative 2. I want to have these points. So put numbers lower than negative 2. Let's put negative 3, for instance. So if I put negative 3 over here, I will get negative 1, because negative 3 plus 2 is negative 1. Square will give me 1. And negative 3 times 1 would give me negative 3, but we're looking for concave up. This is negative. If we got negative, it means it's concave down. So let's look for this specific interval. Let's plug negative 1. If I plug negative 1, I would get 1. 1 squared is 1. No matter what, guys, since this is squared, I will always get positive. So just think about it as a positive value. Times negative 1, which will give me negative 1 times, I don't know, 1. And this is also a negative value. So now I'm stuck with 0 or greater. Actually, I can't even use 0 either, because at 0, I don't have concavity. So let's plug 1. 1 times 3 squared, which is 9, will give me 9, which is a positive value. So I got positive. And that means my concavity is required for x to be greater than 0. Question number 10. If y equals to this, then at x equals this, dy dx. So basically, guys, you're going to use your product rule, which is, let's say, I don't know, a times b. I'm just going to say a and b are functions. If you want to take the derivative of a times b, you have to just do a prime times b plus b prime times a. All right? So over here, I'm just going to say, since sine and cosine are different separate functions, I'm just going to say take the derivative of sine x, which is cosine of x. Cosine of x. And multiply with the second, which is cosine of x, plus now take the derivative of the second element, which is cosine of x. Now take the derivative, and that will be giving you negative sine of x times sine of x, which is our first element. And then this will give me cosine square of x plus, yeah, minus sine of x, sine square of x. I'm sorry. Now we got our derivative, guys. This is dy dx. And now we want to plug x equals to pi over 3. I usually convert pi values to degrees because I usually know the degrees. You might memorize any kind of sine and cosine values. Just going to use that. All right. A quick microphone issue. So, now, pi is equal to 180 degrees, so pi over 3 is 60 degrees, and I'm asked to find cosine of 60 squared minus sine of 60 squared. Now, cosine of 60 is 1/2. So I'm gonna get 1/2 squared, which is 1/4, minus sine of 60 is let me just try this triangle. 60 square root of 3, 1, no, 2. Yeah. So sine of 60 would be square root of 3 over 2. And if I square this, I would get 3 over 4. So basically, I got 1 over 4 minus 3 over 4, and that would be negative 2 over 4, which is negative 1/2. Question number 11. Limits x approaches to -3. What is this? So basically, guys, I'm not even going to plug this negative x to this thing because it's obvious that I will get 0 over 0. They're planning to trick you. So don't use your time. Don't waste your time by just plugging the x value into this. And you have two options. Either you will use Hopital's rule, which is, I don't know, I usually don't, or you're going to just make it simpler, write it down simpler, and you're just going to cancel out some terms, and then you're going to be able to plug it, which I will do because I don't know, it looks simpler for me. Well, you can also use Hopital as well. It's so useful for many cases. So for the top, I'm just going to say x minus 3 times x plus 3 over, and over here, I just can see it's x minus 5 times x plus 3. So x squared plus 3x minus 5x, which is negative 2x, times negative 15, which gives me that value. So I just can cancel this x plus 3's, and I end up with x minus 3 over x minus 5. Just plug your negative 3 over here, and you would end up with negative 6 over negative 8, which is 3 over 4. Answer choice C. So the average rate of change, guys, so basically, if we call this B and this EA, all right, it's just f of B minus f of A divided by B minus A. And in this case, f of B, which is cosine of 2x, actually cosine of pi, minus f of A, which is cosine of 0, divided by pi over 2. All right. For cosine of pi, I would get negative 1 on the top. And for negative cosine of 0, I would get negative 1 because negative times or minus 1 because cosine of 0 is 1. So minus 1 would be negative 1 minus 1 divided by pi over 2. All right, so you got negative 2 over pi over 2. And flip the bottom to the top, you got negative 4 divided by pi. Answer choice A. So this is a differential equation question. Now you're asked to find dy over dx. We're gonna just treat these as just simple variables. Like you're gonna use implicit differentiation, if you may. So let's just differentiate this. 3y squared times y prime plus y prime equals to 2x times x prime. And I want y prime over x prime. So let's just do that. So in y prime parentheses, I'm just going to distribute it inside. 3y squared plus 1 is this left side. I just took this y prime out of the left, so I can just use my y prime as a just single variable, and I can divide it with x prime. Equals to 2x times x prime. And now, what should I do? Just send this over here and send the x prime over here. You would end up with y prime over x prime, which is dy dx, is equal to 2x over 3y squared plus 1. Do I have that? Oh, yeah, I have that. So they just wrote that one in the left. So I was just wondering where was the answer choice. So question number 14. The graph of y equals to f of x on a closed interval is shown above. Which of the following could be the graph of y equals to f prime of x? So if they're asking for f prime of x, also for an FYI, f prime of x is actually your slope, is a representative of your slope for your actual function. So in this case, you're gonna have f prime, which is negative because you're going downwards. You have a negative slope. So cancel this, and you're stuck with these two options. So you got 0 here, you got 0 here. Your only difference, also this is 0 because the slope is 0 over there. The only difference is the f prime is moving or not. Is this a linear f prime or not a linear f prime? So basically, we're just gonna check the concavity real roughly. And over here, I can see there is the concave down, where here I got a concave up, also concave down here. Like basically, when I check this concavity, I can say there is changes for the concavity for the double f of x, like f double prime. So basically, in this case, we have to have a f of x which has a changing slope, unlike answer choice C. All right, let f be the function defined above. Which of the following statements about f are true? So limit x approaches 1 from the left side. In this case, I'm going to get 1 because if I just plug 1 over there, I got 3 times negative 3 times 1 minus 2, which is just 1. And over here, if I just plug 1 from the right side, I got ln times 0, 1, because 3 times 1 is 3 minus 2 is 3 minus 2, and that will give me ln of 1. And you have to know anything's power to 0 is going to be 1. So if I'm asked to find ln of 1, it's just 0. So this is not equal. 1 is not equal to 0. False. And limit f second derivative, basically, guys, this is a dead giveaway because there's no second derivative, because for guys, in order to be able to differentiate something, you have to make sure you have existing limits, okay? And for existing limits, you have to basically from the left hand side and from the right hand side, you have to meet the same value for that function. In this case, for 1, we don't meet the same value, so we don't have a limit. If we don't have a limit, we cannot differentiate that. So f is not differentiable at x equals 1 is the only true statement. No, it's not the true statement either, because f is differentiable. It's not differentiable, as I said. And over here, it's wrong because there's f prime. They're assuming it's differentiable, which is totally incorrect. So the answer choice is going to be A. The function f is defined by this. The application of mean value theorem to f on the interval guarantees the existence of c value where blah, blah, blah. So guys, the mean value theorem, f prime of c equals to fb minus fa over b minus a. So it means that there should be a c value between this interval, which will actually, the slope will satisfy this. So I'm not going to go into the details of the proof of mean value theorem, but basically you just have to know what the mean value theorem is, and you're just going to plug these values in, and I'm just going to plug 3 over here, and I got 2 times 27 minus 9 times 4 is 36 plus 1, so negative 35, 54. What do I got? 19? Is that correct? Yeah, I got 19. So 19 minus, now what's f of a? 2 minus 4 plus 1. So I got negative 1, divided by 3 minus 1. And now we're getting somewhere. I got 20 over 2, which is answer choice C. Velocity, question number 17. The velocity v in meters per second of a certain type of wave is given by this equation, where h is a depth in meters of the water through which the wave moves. What is the rate of change in meters per second meter of the velocity of the wave with respect to the depth of water when the water depth is 2 meters? So basically, guys, it's asking for the rate of change. So just take the derivative of the velocity function, and that would give you taking the derivative, 3 times h to the 1/2 power, and 3/2 times 1 over radical radical h to the negative 1/2, and yeah, and you will get 3 over 2 radical h as your derivative. The reason why I took the derivative is just so simple. It was just the rate of change in meter per second meter, and then what will happen is now I'm just going to plug 2 because my depth is 2. So 3 over 2 radical 2. And that's answer choice C. If dy dt is negative 10 times e to the power of negative t over 2 and y of 0 is 20, what is the value of y of 6? So guys, over here, this question looks quite complicated. I know that, but it's not that complicated actually when you just simplify things out, because they're actually trying to make you scared by putting all of those e's and those values. Just calm down, guys. Over here, I got my f prime of t, which will be negative 10 e to the negative t over 2. And I have the value of f of 0. F of 0, just make sure, just catch my words, guys. I'm not taking the derivative over here. They're just giving me the f0, which is 20. And now I want f6. How can I do that? Basically, just get rid of that derivative. How do I get rid of that derivative? Awesome. Just use your integral. And what am I going to do that? I'm just going to use 0 to 6 in order to satisfy this form. So 0 to 6. Now you understand when I set up the equation why I'm using these intervals for the definite integral, which I'm working on. And negative 10, actually, I'm just going to put that negative 10 away. E to the negative 1/2 t dt is equal to what? F of 6 minus f of 0, right? Because I just take the antiderivative of that, which gave me the function. And if I plug 6 and subtract with 0, which is my definite integral is supposed to do, I'm actually getting this. And I already have those values. My f of 0 is going to be 20. So there's just one unknown in this equation. It's just f of 6. Now just find f of 6 by taking the integral. So it will be negative 10 times integral. What is the integral over here? So it will be just negative 2 times e to the negative 1/2 t all the way to 0 to 6. So it is equal to f of 6 minus 20. So what happens when I do this? So basically, if I just put this over here, I got positive 20. Negative 2 times negative 10 is 20. And e to the power of negative 1/2 t, and plug 6 to 0 for t. So when I plug 6, I got e to the negative 3. And when I plug 0, I just get 0. So I didn't even mind to do that. And since I'm looking for my y6, it should be answer choice B, since I got this already. Let f be the function. Let f be the function with derivative defined by f prime is this, at which of the following of x does the graph of f has a point of inflection. So guys, for points of inflection, just make sure you're looking to the right spot. You have to take the second derivative in order to find the points of inflection. Now we have the first derivative, so we're basically going to take the second derivative by derive it again. So taking the derivative, I got 3x squared minus 4. Now, I have to set this equal to 0 in order to find my point of inflection. Also, you have to make sure that you're changing signs, but in this case, it's obvious that I will change signs. If I had something squared in parentheses, I should have just checked that case, but like, just make sure that you're changing signs. And 3x squared equals 4, x squared equals to 4 over 3, and you just square that, and you got 2 over radical 3, which is answer choice C. Let be the function f be the function given by this if the line y b equals to b is a horizontal asymptote to the function graph of f, then b is equal to what? So how can I find my horizontal asymptote? Basically, in questions like this, you just find your x squares, if you may, like just multiply this and you would get 2x squared. In the bottom, it's obvious that I'm going to get something x squared. Just cross these things out and you'll get 2 as your constant, if you may. And usually we solve this kind of horizontal asymptote questions by looking at the constant, what you left with. And in this case, it's 2. In college level students, there are a lot of ways to calculate the horizontal asymptote. I know that, I'm aware of that. But for AP Calculus AB level, basically, you're just doing this, which isn't actually like illogical, but it actually makes sense. But how can I say this? It's just a faster way, I guess. Question number 21. Base of a solid is the region bounded by the x-axis, and the graph of y is this. For the solid, each cross-section perpendicular to the x-axis is a square. So this is an important detail, a square. What is the volume of the solid? So basically, our function is y equals to radical 1 minus x squared. If I just take the square, also note that your zeros are at x equals to x1 is 1 and x2 is negative 1. So your region should be 1 to negative 1 in this case. So if I just do negative 1 and 1, and you have to have your region bounded inside of this semicircle, and you're gonna have squares, and this semicircle actually is a representative of your 1 minus radical 1 minus x squared. So just keep that in mind, and also over here you got y squared equals to 1 minus x squared, and y squared plus x squared is 1. So basically, that's how you come to this semicircle in your graph if this is your actual radical 1 minus x squared. And what should I do now? So basically, if you want to take the volume, you're just going to write your endpoints over here, in this case, negative 1 and 1, and take the thing you want to take the integral of, which is 1 minus x squared, in radical form, of course. Also, and you have to square this because you're taking a square. If this was a circle, you would do pi, I'm not sure, 3 pi over 8 or 5 pi over 8, I have to look that up, times the square of that. There's also many proofs and ways to find the equations, but for squares, we're just going to do x squared because it's x squared. And then dx. And now you're just going to do this, and you know that squares and radicals just cancel out each other. Since the inside of the radical has to be positive, I don't even need to write the absolute value over here. So I just got 1 minus x squared negative 1 to 1. All right, so over here, taking the integral, I got x minus x cubed over 3 to 1 to -1. And now just plug those values in. 1 minus 1 over 3 in parentheses minus, now plug -1, -1 as well. So I got positive 1 over 3, and this will give me -2 over 3. And over here, I got 2 over 3 as well, and this ends up being a positive since this is a negative as well. And I got 4 over, 3 as my answer choice B. That was it for today, guys. I hope you liked and enjoyed this video. If so, you can just drop a like down below. I'm planning to make a part 2 of this AP Calculus question series, so it will really help me a lot if you just show your support by subscribing me and liking my videos. I hope you have a pleasant day.